Welcome to this third installment in the Working with Legacy Code series. Last episode, we wrote some tests to try to better understand what the system was actually doing. In the episode before that, we used a refactoring technique called Breakout Object to extract from a really large class, a class that's hard to test, extract the code that we needed to work with into a new class that we could more easily test. And that's what we did in the last video. Now we actually get to start refactoring the implementation, the code that we need to work with, and we're going to fix the bug that, the original task that we set out to do. And we'll also actually get to fix some bugs, some other bugs that we discovered along the way, thanks to our characterization tests that we wrote in the previous episode. So just a quick recap, the bug that we're trying to fix, it's a relatively simple bug. It's in this form here, and the problem that we have right now is that when we set the date to a date that is invalid according to application rules, so for instance, if I was born yesterday, I am less than 18 years old, and people less than 18 years old cannot fill out this form. So rightfully, it's showing us this label, invalid date. You guys didn't see it because it's behind that picture of my face, but there's also a flash message here that says, date must be, date of birth must be, I think, more than 18 years old or something like that. Now, the problem is, the bug is that when we change the date to a date that should be valid, for instance, 40-ish years old, we're still getting that invalid date label. When we wrote our test in the last episode, I think I kind of detected where the problem is, so we'll get to fix that today. But before we go ahead and fix the bug, we're going to refactor the code a little bit and make it easier to reason about, easier to work with. And we're going to start by actually cleaning up our test file here, birthdate_validator.spec.ts. We've got our test cases, the data of our test cases here at the top. But here are the actual the test implementation. There's a bit of duplication here, right? Nothing terrible, and it's much better than if we had, all that setup code that we extracted to this class here. It's much better to have this kind of builder pattern here, but we can probably eliminate some of that duplication too. And so that's what we're going to do. And we're going to do that by using the before each function from the Jasmine API. And what this does is basically it runs this piece of code before each test. Each of these here, it will run the before each code that we put in there. And so that's a good place to put that setup code. I try to avoid using that as much as I can. I prefer to use like custom setup methods that I'll build myself. But in this case, I think it's fine. So we'll just have two variables here. One's the builder of type birth date valid. You know what? That's a horrible name. I don't really like it. Let's change that to let's change it to just birth date validator test builder or test helper. It is a builder. It's the builder pattern. Let's just call it test builder. Yeah. Okay. And not much of a difference in the end. And then we need a reference to the birth date. Right. You know what? Let's just call it validator. And that'll be a birth date validator. Now, all we need to do in here now is to copy this code here in here. We don't need the const. We're assigning it to, oh, and now it's validator. go. It's not picking it up. Oh, because we're not reading from it. Yep. Okay. Validator. There we go. Okay, so now we just need to change this to validator, get rid of that. Actually, let's clean this up a little bit. Oops. Okay. Like that. We can get rid of this here. This is now validator. Get rid of that extra space. Again, we can get rid of all of this. Validator. And I think that's it, right? So it's leaner. We've extracted the duplication to this before each section of the code, and our tests are still running and passing. Great. Do we want to change anything else in here? Actually, yeah, there's no real reason why these test cases would be inside that describe, that top level describe. Although I guess there's nothing wrong with it either. It would just make it, I think, easier to read and understand that. Yeah, so this is all part of the actual implementation of our tests here. This is the data, and this is, you know, the kind of the test functions. And yeah, so that's fine. What we could do is extract that helper or builder class to its own file. I think that would be appropriate. So let's go ahead and do that. I think I can just use the, move to new file. Oh yeah, but the only problem with TypeScript though is that that refactoring, they don't use the most common style for file names, and certainly not the one we're using in this project. So let's just birth date validator test builder. So birth date validator test builder. There we go. And it should update everywhere else that it's using it. Yes. And that's why our tests are still running. If we look at the top, see it changed it. Great. Okay, so that's fine. So I think that's adequate in terms of what our test file looks like. One thing we could decide to do is actually put the data for the test in a separate file. I'm not going to do that. But it could be, you know, there's a lot of data, so it could be smart to do that. Have this file be a little smaller and really just contain the test implementation. But I'm not going to do it. Not for now, anyways. Okay, so let's look at this class that we extracted. That's our command object, right? Our method object that we extracted from this big applicant personal info component class. We did that in the first video. And just to give you guys, put you back into the context. No, it's validate birth date. This one, yeah. Okay, so what we basically did is take the body of this function here that contains the code that is involved with the birth date validation that we're supposed to be working with. We extracted that to this new birth date validator class that we created here. So now what we want to do is clean this up a little bit, refactor it so that it's easier to reason about, understand, read, and modify as we need to right now and maybe in the future. So the first thing I'll start by doing, and I often like to do when I'm trying to do these refactors, is actually look for local temporary variables and promote them to fields in the class itself. It often makes it easier to move stuff around and extract functions. So that's what we're going to do. So the first one is that is valid. So let's do private is valid. And it looks like we're starting that function with setting it with true. So we can go ahead and actually do that right here. And now I can delete it and just make sure that I add this wherever we're using it. So if you'd be working in C#, for instance, you wouldn't have to do that, though you could, using the this is optional. Okay, and the next thing that we see is this temp date that we're using in these conditionals here. And these conditionals are kind of our application rules for checking if the birth date is, I guess, older than 125 or younger than 18. And so we could promote that here by doing private temp date equals, no, actually, we can't initialize it here because it's using the component, which we're getting through the constructor. So let's do that in here. And then we can do this temp date, and Copilot knows what we're trying to do. Good. For some reason it added how many curly braces did it add? Okay, there we go. I think we're good. Yeah. Okay. And okay, we can delete this. And notice that, we need to make sure that our tests are passing as we're doing this. Now, of course, the build is broken because we're missing these. This is in front of. Oh, oops. Oops. There we go. And here. Okay, and our test should still pass. Yes, good. Now, let's see. This is complaining because implicit any. Yes, that's true. Sorry about that. Date. All right, so what next? One of the first things I would probably extract to other functions, well-named functions, to make this validate function easier to read is those conditionals that have to do with the date. So let's go ahead and do that. We'll extract this one here, which we know checks that it's I guess if this is true, then it's the case that we are younger than 18 years old. So let's extract that to a new function and call it is younger than 18. All right. Good. And let's do the same thing with this 125 years old condition. And actually, you know what? We know that this doesn't work. We've determined that when we wrote our tests. Let me show you. Right, so this is an example of a date that is valid. So it's returning from validate, it returns true. It doesn't flash an error message, and it doesn't set the is invalid property on our date picker component, which I think is the source of our bug, but we'll get back to this. Now, if we look at this here, this is an example of a case where we're too young. We're younger than 18, obviously, right? The birth date is in 2021, and we are in 2021. So correctly, the function returns false and flashes the message age must not be less than 18 years, and it sets the property is invalid to true. Now here's an example of when we're way older than 125. Yet, as of now, the behavior of the system is that the validate function returns true. It doesn't flash a message, and it doesn't set is invalid to true. So we know that this doesn't work. There's a problem, I would think, with this the implementation of this condition. We're going to look into this, but just before we do, let's extract it the same way we did with is younger than 18, and then we'll worry about figuring out what's wrong with it. So we're actually going to lie here for a second, right? Because we're extracting yes, and we're going to say is older than 125, but really this is not working right now. So and I'll just change the order. I like to place my my private functions kind of in order of how they're being called for my public functions. So first we're calling the where is it? Is younger. So is younger is here, and we're moving as we're reading, and then is older. So that's the next one here. Okay, so now we want to fix this bug here. That's not like our bug ticket that we have from QA. That's not it, right? But as we were writing tests for this part of the system, we realized that there was a problem. Clearly, the intent when we're looking at the code is for a message to appear that says that age must not be more than 125, and we should set the field to invalidate, but it's not doing that right now. So there's a bug, and I think it's safe that we fix it. I don't think there's any other part of the system that depends on this weird bug where we're not quite validating the date properly. I think it's pretty safe to do. So we're going to go ahead and do that. But before we do, since we're changing the behavior of the system, we need to change our tests accordingly. Now we could change our implementation and then change the test to match that, but it's better to change the tests first to what we want to happen, and then make our implementation changes that will make those tests pass. So what do we want? Well, we would logically, wherever right now we're detecting that there is age must not be less than 18 years, we should have the same for the 125, right? So we're going to look in our test cases, the data in our test cases, where we have this, and then we'll do the corresponding thing for the date that is older than 125. So return value should be false, right? We should be flashing a message, and that message, is this here. I think I forgot yep. There we go. And do we have a period? Yes, we do. And is invalid should be set to true on our date picker. Now we'll just copy all of that and just find wherever that applies. So here's another one that we would expect that the same rules apply. Here's another one. Here's another one. And I think that's it. Notice that we didn't have to change our test implementation, because the way we did things is we've got our, we're taking in as parameters to our tests this data here through a for each or a for loop. So that's a pretty nice trick. Okay. Now, of course, 11 failed, right? Because this doesn't work. We knew that. So why does it fail? If we look at this real quick, what are we doing here? We're taking the full year. Okay, so actually, temp date. I don't like this. This is the birth date, the date of birth, right? we're taking this string, this date of birth string, we're creating a data object from it, and for some reason we're calling that temp date, but let's just call it date of birth. There we go. So we're taking the date of birth year. If we're looking at the 18, the younger than 18, and that one works. So let's look at that one first. So we're taking the birth year, we're adding 18, and we're checking that the result is bigger than the current date, which makes sense, right? Because if you're, for instance, if we're in 2020, right now we're in 2021, but the birth date was in 2020, add 18 years to that, you're way past 2021, which is the current year, right? So that's the correct behavior. Now, this doesn't work here. It's a similar thing, but obviously that's what happens when you don't write tests, right? And you kind of just implement stuff. Because let's think about this. What we're doing here is taking the birth date. So let's pretend that the birth date is 1500. 1500. We're reducing that by 125. So now we're in 1375. And we're checking to see if that is bigger than the current date, which obviously it isn't, right? So I think what we actually need to do is probably add, just like we did with the other one, 125, but flip this here. Is that right? Yeah, I think so. Let's just confirm. Well, actually the test will tell us. There we go. Okay, but just so that visually we understand what we just did. So what I did is, like, let's say we're in 1500, we add 125, now we're in 1625. Is that less than the current date? Now, of course, that's not the best way to showcase this, but let's take exactly 125 years. So if we're in 2021 and 125 years, this would be valid. That's the oldest birth date that would be valid, 1896. So if we were to do 1895 plus 125, we end up in 2021, and that is less than the new date. So indeed we are older than 125. If we did what was it, 1866, that was valid. So 1867 would be good, right? But barely. So 1867 plus 125, no, that's not right. Let me just do that again. What was it? 2021 minus 100. Oh no, yeah, minus 100. 1896. Oh, 1896, right? So 1897 plus 125 brings us to 2022. And now, is 2022 less than 2021? No, false. Though we are not older than 125. All right, so hope that clarifies things a little bit. Okay, so great. So we just changed the behavior of our system safely with some tests, and we've improved things here. Oh, and actually, let's confirm that with a little bit of a manual test here, I guess. Let me just refresh this so that we get our changes. Meanwhile, I don't want to forget, there's another important thing we need to change, and that is this problem here. We are depending on the system clock. So our tests are passing right now, right? Because we're dealing with years and they're pretty big. But as days and months and years go by, our tests are going to start failing because those conditions will start being false instead of true when they should be, or whatever, you know what I mean. So if we're using 2021 here, which we are because that's the current date of our system, then our tests here with these dates work the way they should. But as days are going by, as time goes by, then that new date in our tests is no longer the same, right? So that's why you shouldn't depend on the system clock directly, because it screws up your tests. It makes tests much harder. Oh yeah, let's take a look at our, here we go. So before, if we set a date that was older than 125 years, it wouldn't be a problem. It wasn't flagging it as invalid. So let's see if now it does. Let's go with 1714. Invalid date, and you guys aren't seeing it because it's hidden behind my, but there's age must not be more than 125 years. There's a little flash message here. So great, that's working. It wasn't before. Okay, let's keep, actually let's do this. Let's take care of this thing here. So now what we want to do, and this will require just a little bit of work, right? Because we've got so much data for our tests, but not too bad. What we want is to actually have a current date as a parameter. And yeah, we can do that. But actually we'll use 2021, right? Because we should probably be using today's date because that's what we built our tests on. And actually let's use a string. Just so that it kind of looks like we're going to be expecting a date. So that's fine. I prefer that than to using string, but just so that it kind of looks like the date of birth. Right now our system is taking in a string. So let's do the same thing. We'll make that value a date, but we'll pass that string to the date object just so it looks kind of the same. So what's today? It was 0904, right? And we're going to be adding that to all of our test cases as the current date. So a little bit of work here, but not too much. It would be much worse if we had to, if we hadn't extracted some duplication in the actual implementation of our tests. Then we'd have a lot more work to do to add this change in our API, if you will. Now all we have to worry is just add this piece of data to these test cases, and then we're going to change in only one place the test implementation, and that'll be that. So not too bad. We've got 24 of these test cases, and they cover every possible state, I think, of our system, the piece of the system that we're testing. So that's pretty good coverage, right? 72 tests in all for that little class. Okay, so now what we need to change, we're going to change our builder so that we can pass in that parameter. So with current date, right? Thank you, Copilot. Now we didn't implement this yet, so we're going to be doing that with current date. Oh yeah, we put that in a different file now. So let's go here. So, and we're going to be adding it right here. With current date, it takes in a date, returns this. Okay, return this. Return this. Okay, now what are we doing? We got to pass that in to the constructor as a dependency. So what we're going to do is this dot, no. What's it called? Birth date, yeah. So we've got that as an instance variable here. So this birth date validator is going to be equal a new birth date validator. That is going to take in the date validator mock. And null, no, not null. We want, what's our second parameter? Final validation. So whatever we already had here as a value for final validation, we want to make sure that we're taking that again. And I think right now this is a private variable. So let's just to make things a little easier here, let's make this public read only. I don't think there's much harm in making this public. And ideally, eventually, in either this set of refactoring or in the future, we would probably want to find a way to get rid of this flag parameter. So I'm not too worried about making this public. Right, and then this would be this dot birth date validator dot final validation. Oops. Often do that. Press enter instead of tab to get the suggestion that the ID is giving us. Okay, and now here's what we want. We want to pass in as a third parameter our date. Do I want to just pass in a date? Yeah, we could do that. I think that would be fine. Or you know what, it would probably be better to pass in a function that returns a date. Yeah, it might give us a bit more flexibility. I don't know, I'm debating this. Either would work, I think. So, but yeah, let's go with that. Let's go with that. And okay, so now it's telling us that our constructor obviously is not built for this. Oh, we should have the same thing here since we're changing the, and if we didn't, it would probably tell us anyways, or maybe not, because I think what we're going to do is actually use a default of the current date. Yeah, that's what we're going to do, I think. Okay, so let's do that. Let's make this work. We're going to make this pub. Oh wait, what did I just do? That didn't make sense. Right? There's no. What I actually meant to do is we need to grab this from the birth date validator dot. What are we going to be calling this? Current date, I guess. Yeah, I think so. So public read only current date will be, it will default to a function that actually, I think we can just pass in date, the date constructor. Yeah. And then it will, yeah, that works, I think. Argument of type is not assignable type date. Yeah, okay. All right, let's just be. Oh, yeah, because I meant to do this. Does that work? Type date is not assignable to type string. That's the date constructor. That's kind of what we want. Why is this expecting a string? That's interesting. Date is a date. We're calling this. It's expecting a date constructor. And now it's saying type date is not assignable to type string. Huh. Okay, well, yeah, let's just stop messing with this and just go like that, like this. And that, I think, is not working. What am I doing? Oh. That's what I'm doing wrong. There we go. Okay. Okay, so that works. And. Our tests are passing, but that's normal because we didn't actually change. We're not using it yet in the. So let's use it and see if this works. So this dot current date and this dot current date. Okay, so our tests are passing now. Yeah, you would expect them to because the dates are all the real. I guess if we really want to know if our way of passing in the parameters working properly, we could add some test cases that are using different current dates, but you know, might be overkill here to test. Let's see, let's do. So we would expect a birth date, a current date of 1980 with a birth date of 1979 to be a problem, and it is, right? Okay, perfect. There we go. That's good. All right, so we no longer depend on the system clock. We now have a nice way to inject whatever date we want as our current date, allowing us to write tests in a flexible, maintainable, and solid way. You know, like it won't break as days go by. Okay, so what else can we refactor about this and to better understand what's going on and make the function more readable? Well, we've extracted those conditionals. Now, okay, we've got quite a bit of duplication here, right? We're setting this is valid to false, and we're setting birth date and valid date to true, and we're querying this array for this object for our particular birth date picker component. So we're doing all of the work here, and really these 4 lines, except for the messages that change, are the same as these ones, right? So the way we handle when a date is invalid, whether it's that it's younger than 18 and older than 125, is virtually the same. So there's probably some thing we can do here to get rid of some of that duplication. So how about, okay, so these are almost the same, but there's a bit of a difference. So let's forget about that one for now and just extract this, the work we're doing here, right? And, oh, there we go. And let's call that set date as invalid, I guess, or just handle invalid. That's a bit too broad, because really what we're doing in those 3 lines is really we're just setting like we're setting 2 variables or property related to the validity. So set, I would say set date as invalid. Yeah. Tests are still passing. Let's use it in here as well. Well, there we go. Reducing the duplication here, the length of this function. Just became a little easier to read, right? Now this component is smart move active, and if it's younger than 18, then we set the date as invalid, and we're flashing this message. So that's cool. We can probably go a little further here. We've got this component smart move active twice here. I don't know exactly why we would only want to check the validity of the date when smart move is active. I don't have enough knowledge about that form and that process to answer that question. So we're going to keep that functionality, make sure we're not breaking anything, because I don't know what else depends on that. What seems like a weird behavior to me, but We're going to operate with the thinking that there's a reason for this. So, but what I would do, I think, is just split that up like that. So we can remove the duplication here and here. And then we can just copy that inside like that. It adds a level of nesting, which, do we have an extra parentheses here? Oddly enough, we're compiling. What is this for? Oh, yeah, there we go. Okay, so if smart move is active, then if it's younger than 18, set as invalid, flash that message if it's older. Okay, so here's one thing we could do. We don't really need that else statement here because those are mutually exclusive. So yeah, you know, technically, if we're checking that we're younger than 18, and we are, we don't really need to check if we're older than 125. Sure, you know, we'd be saving a few CPU cycles, but it's really not a problem. And I think it's going to make code a little easier to read if we just go like this, right? So if that, and this is what happens. If this is what happened. I don't know if it's just me, but else I find is often more confusing. It's harder to read than just if statements by themselves. And I find it's often the case that you can, with early returns and different ways, you can get rid of those if, else, else if, and else if, and else, and there's like all this nesting. And okay, if this is younger than 18, we do that, and we do this. Okay, so here's another duplication. We did extract some of it, but really we're dealing with the same, you know, in both of these are slightly different in terms of conditions, but they are both the same concept. The date's not valid, right? So why don't we and really the only reason why we need to differentiate here between those two is that we're flashing different messages. So, okay, I think I've got an idea that would make it a little easier to read, a little cleaner. So let's start by getting rid of these two calls, right? Really, okay, what we're going to do is we're going to add a check for simply is it valid. So let's do that. So private is date valid. The Copilot is great, but sometimes these suggestions are kind of in the way. So is date valid? We'll return a Boolean. Actually, I like to be explicit with my return most of the time, unless it's a function that only has side effects and doesn't return anything. I don't necessarily see the need to type it as void or undefined, but for everything else I like to be explicit. All right, so basically if the date is date valid really is just return this is younger than 18. Oh, actually, if it's not younger than 18 and it's not older than 125, then it is valid. So what we're going to do is if this component is smart move active, and this dot is date valid. We're going to negate that, right? So if it's invalid, then we set date as invalid. So we don't need that here anymore, right? So now we're left with what? Two conditionals that are only have as a purpose the flashing of a message that is particular to those. So we can extract this, push that down to a lower level of abstraction, and simply call this dot flash message. Flash warning message. Yeah. There we go. So we're reading this function. Our tests are still passing, great. So we're reading this function. All we now need to worry about is when we look at what the validate does is, all right, it's checking if smart move is active, and if the date is invalid, it sets the date as invalid. So that's not very, it's kind of confusing, but we can think of a better name, and then flashes a message. If the date is valid or not, right, we keep going. This here applies no matter if smart move is active or not, and no matter if our date is valid or not. Then we check for this other flag, final validation. If it is, we return is valid along with the result of this other function, which this is really super weird. But again, we're just here to fix a small bug. I don't want to rework this entire huge class and try to understand how everything works in there. There's obviously some bizarre thing going on where we're passing through the validate birth date function to validate the rest of the dates when we're submitting the form. These things should be happening separately, but anyways. And then we return either the union of these two, right? Or the intersection, whatever, right? We're returning this and that. Or if it's not final validation, then we're just returning is valid. So I think this is much easier to understand at a much higher level of abstraction. Someone that's just trying to understand what this does can easily read this and doesn't have to worry about the implementation details of how we're actually doing everything. Can we think of a better name? Set date as invalid. How about, because really what we're interested in here is we're setting the date picker component as invalid. How about just flag as invalid? Or mark, okay, mark as invalid. Mark as invalid. All right, so we're checking if it's if not, we're marking it as invalid, whatever that means. If we're interested, we can look at the details. If not, it's pretty obvious that, all right, we're just marking it as invalid. And then we're flashing a warning message. This here, I don't know that there's much we can do about it. I would really like to get rid of this flag parameter. Unfortunately, that would require some refactoring of this class here, and I don't think it's worth trying to do that right now, given that we're working on a pretty small UI bug. But that's something that might be done at another time. Okay, so our tests are still passing. Our class is getting much easier to read. Let's reorder our functions here so that they are in the same order that they appear in our public function. Date is valid, mark as invalid would be the next one. And then we move on to flash message service. And that in itself is calling is younger than 18 and is older than 25. There we go. This is starting to look pretty good. One thing that we could do maybe is, does it make sense to break these two apart? I don't think so. Okay, so I think in terms of refactoring, we did pretty well. We did improve the code. Now we can worry about trying to fix our bug. Now the problem was, remember, that our date invalid label on the field in the form would stay there when we would set the date to a date that was valid. And it seems pretty obvious to me now, looking at our tests and this flag here, that our problem is that when we have an invalid date, we mark as invalid, right? So we set is valid to false, but we set invalid date on our date picker component in the form, right? We set that to true. But what happens when the date is valid? So when this doesn't happen here, this is the only code that runs. So it, I guess, is valid. The property is valid remains true. So the return from this function will be okay. And that's what we see from our tests, right? When it's a good, like the date is valid, we do return true. But is invalid on the property, on the, on the date picker component from the form, that's not being set to false, right? So if previously it was set to true because the date was previously set to an invalid date, then it wouldn't change. It would still be showing up as is invalid true, and therefore that label would remain there. I'm pretty sure that's what's going on. So what we want, and we're going to start by modifying our test cases to reflect what we want. What we want is for when the date is correct, and okay, we got to be careful here though. Hold on. Right, so we're only setting, yeah, the system right now, we're only setting or marking as invalid the date picker component when is smart move active. So we would want to logically, anyways, kind of keep that rule when we're setting it as not invalid, as valid, basically, right? So we got to be careful about that. Okay, so is smart move active true? So that we can go ahead and say, all right, so if the return value is true and the date is valid, then is invalid should be set to false. Okay. Is smart move active false? So we're not going to change these. Is smart move active true? Then yep, we would want this. Since the return value is true, it is then, is invalid is then false. Is smart move active true? So this would be the same thing here. We would want this to be false. Smart move active true. Yeah, okay. Smart move active false. We're not touching that one. Smart move active true. Okay, we can change that to false. And these are already fine. See, we already, when date is invalid, we're doing that properly. Smart move active false. We're not touching that. Smart move active false. We're not touching that. Okay, so now we've got 4 failing test cases. Let's change our implementation to make those tests pass. Let's grab a sip of water here. Okay, so it seems pretty obvious to me that what we need to do is have kind of a mark as valid function that would be essentially doing the same thing, well, the reverse of mark as valid, right? It would be doing that, and then this is valid would be true. which I guess we don't really need to set because we're starting off with that as being true, but I'd rather not rely on that and be explicit about it, since this is really the reverse of that function here. And then let birth date, blah, 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 birth date invalid date equals false, yeah. Okay. Mark as valid, mark as invalid, mark as valid. We could probably parameterize that, but again, I'm not a fan of that. Boolean flags as parameters, and so this is fine. This is explicit. I like this. Okay, now this would be called when, I guess, else. No, that's not right, because we do need that. Okay, so let's extract that at a higher level. If this component dot is smart move active, and then inside of that we're going to be doing these. So if the date's not valid, you do that. Else, you do this. Mark as valid. So it muddies our function here a little bit, unfortunately. But there we go. Our tests are passing. And let's do a little manual test here. We'll refresh this thing. And while it does that, we're going to think for a second if there is a cleaner way to do this. Well, there is a way to see. I really don't like nesting. I find it makes it a lot harder to read functions. One option would be to do it this way, which I think also has its negative points. So we actually, let's just do that. Add this here. Forget about our else. Forget about this. All right, and then we can just do another if, basically. This and this is date valid. This mark as valid. All right, this would be another way to do this. It's got the advantage here is it doesn't have the nesting. Takes up less lines of code, actually. It seems a little silly because we're kind of just inverting this here. Let's add a space. I don't know which one I prefer. Just really worried about readability here. I don't care about CPU cycles. This kind of stuff is obviously we're doing work, you know, that more than once that we don't need to. We could be saving some of those things in local variables, and if we worried about like CPU cycles, but it doesn't make sense to worry about CPU cycles for some stuff like that. So we just worry about readability, and I think this is by an inch, you know. I prefer this. Yep, I think this is more readable. One thing that we could think about is whether we would want the date validity to be the first of these conditions, and I think that makes sense. That's really the important component in this. This is a date validation class, and it's a validate function. So let's make the validity of the date, you know, the predominant factor here, the one that jumps out to the reader first. The fact that smart move active needs to be true is kind of a side thing that we don't really understand. But we just know that that's how the system's built right now. We don't want to break that. So I think that's all right. Smart move active, you do this, you do that. And if this is you do this, right? Okay, that works. Our tests are passing. I'm pretty happy. Let's just make sure with a quick manual test that does indeed fix our problem. So this state is invalid. Age must not be less than 18 years old. That's what we're expecting. Great. Now before, when we would set it after that to a date that is valid, it would still show invalid. Now that should be gone. Still there. That's interesting. Let's look at the code. Are we doing something wrong? If this is date valid return is younger than 19 and this is older than 25. This component, then this mark as valid does what? This is valid true, invalidate false. Mark as valid, it is the correct one. Is smart move active, is date valid. It's interesting because our tests are passing. Did I not refresh the browser or something? Let's see if it's, well, yeah, let's do that. Probably something real dumb that I'm not noticing. That's always fun when your tests are passing, but your manual tests aren't. Okay, so this should be invalid, more than 25, yep. Now we change that to something that is valid, 1980. Yet the invalidate label is still there, but we didn't get the, yeah, so the bug, the original bug is still there. Okay. If this is date valid and this component is mark move active, then we call this mark as valid. Marks as valid. Mark. Wait a second. Oh yeah, okay. Just a typo. Mark as valid. I am intrigued. There is no case where obviously where this would be both true. How about if we wrap this in here? It shouldn't be a problem, but sometimes you never know. Ah, okay. We just found it. So our tests are compiling just fine, but the actual builder is getting hung up on some weird import that I have. Yep. Don't know how that got imported there, but get rid of it. Now we're compiling properly, which will update our web page here. I could have been looking for a while. Okay, so this is invalid. Now we change it to something older, much older. No, something that's valid, sorry. Okay. There we go. Bug is fixed. Okay. Yeah, I was wondering. Okay, so that's pretty satisfying. We've added a bunch of tests. We've changed the behavior of the system by changing the tests first to match what we expect. Then we changed, our implementation. This is still weird, right? Don't think that this is good design. It's not great. You could argue that this class is breaking the single responsibility principle. We're getting a whole slew of date picker components, including the one that we're interested in, but all of the other ones from the form for some reason, which doesn't make much sense. But it's the way it is. We're also, dealing with the flashing the warning message, and that's another kind of responsibility there. So, it's not perfect. We're passing in a Boolean flag, so we're doing this validate function does a certain thing. Sometimes it does another thing at other time. We've got this other smart move active. So there's still a lot of weird stuff going on. But to fix that, we would need a better understanding of what this 1300 lines of code class is doing. And since we were just fixing a small UI bug here, I think what we did is pretty good, right? We made the code more understandable, more readable. We brought it under test. Further refactorings will be easier because of what we did. And we fixed a bug that it seems like no one knew we actually had, right? We weren't correctly validating for that over 125 years, and now we are. So all around, I think that's pretty good work. Hope you guys enjoyed. I hope you learned a few things that might help you in your own work if you're working with legacy code. Some of the things that you want to maybe remember from these 3 videos is that you want to ideally write some characterization tests before you start refactoring, before you start changing your implementation. And in order to do that, sometimes if you're dealing with a very long function inside a very long and complex class, one of the best thing you can do is to use breakout method object or breakout command object and take that code, bring into a new class that has a reduced dependency on the original class, and then you can more easily bring it under test, work with it, change your code, and do basically everything we just did in these past 3 videos. All right, so if you've got any questions or comments, feel free to contact me or leave them in the comment section of this video. I hope you enjoyed. Have a great day.